Okay. Chapter 2 is all about organizing your data. Let's go over a sample problem and then discuss the definitions and formulas associated with it. For problems 11 through 16, use a specified number of classes to do the following. You're going to find the class width. We're going to make a frequency table showing class limits, class boundaries, midpoints, frequencies, relative frequencies, and cumulative frequencies. Then we're going to draw a histogram. Then we're also going to draw a relative frequency histogram. We will then categorize the basic distribution shape as uniform, mound-shaped, symmetrical, bimodal, skewed left, or skewed right, and then we will draw an ogive. The problem we're going to do is number 13 on page 51. You are assigned problem 11 on page 51. They're pretty similar, so I think you'll be okay. Problem 13 says, certain kinds of tumors tend to recur. The following data represent the lengths of time in months for a tumor to recur after chemotherapy. And then it also says to use 5 classes. Before we start answering A through F, the first thing I would do is to put the data in order from lowest to highest. You can do it the old-fashioned way, or you can use Excel. I like using Excel, so let's go look at how I would do this. And here it is. I just opened up an Excel program, and then I just typed in all the numbers straight down the column. Once you've got all the numbers written down, and notice there are 42 of them, so N, the number of data, equals 42. Once you've typed them all in, then you are going to go up to the column heading where it says A, click on it so that it highlights all of it. Once it's highlighted, then you're going to go up to the sort button, and you can open it and sort it. I clicked on it, so it automatically clicked from highest to lowest, but if you click it again, it'll order it back down from the lowest value to the highest. And if you notice, the lowest value is 1, and if we scroll down, the highest value is 59. Okay, let's go back to the homework problem. We have to determine what the class width is for these values. We will use that information and create our frequency table and all of the items requested in the table. So we're going to be, in order to do this, we need to know the class width so we can do the class limits, class boundaries, and so forth. So let's go to the instructions here. Remember that 1 is the smallest value and 59 is the largest value. Let's talk about first the frequency distribution and table before we decide how to create classes. Okay, a frequency distribution partitions data into classes or intervals and shows how many data values are in each class. The classes, or you can call them intervals as well, are constructed so that each data value will fall into exactly one class. Now remember, they ask us to create 5 classes. Now this is how you find the class width. You're going to take the largest data value, subtract it from the smallest data value, divide it by the desired number of classes. Once you do that, you're going to increase the computed value to the next highest whole number. So I have done that. 59 minus 1 divided by 5 classes, equals 11.6. Now we must increase the computed value. So the class width is going to be 12. Now let's create our table. And I just blacked this out because I just copied it from the book. So you got class limits. Notice class width is going to be 12. So our lowest value is 1, then 12. Then you go up to the next class, 13 to 24, 25 to 36, just 1 through 12. Then the next class width would be 13 through 24. If you notice, 1 plus 12 is 13. 13 plus 12 is 25. 25 plus 12 is 37. 37 plus 12 is 49. Then when you're making your frequency table, we want class limits, which I just explained, then class boundaries, your midpoint, frequency, relative frequency, cumulative frequency. Okay, lower limits, and this is the explanation for this. The lower class limit is the lowest data value that can fit in a class. The upper class limit, 12, 24, 36, 48, and 60, is the highest data value that can fit in a class. The class width is the difference between the lower class limit of one class and the lower class limit of the next class, like I just counted for you. Okay, now the next thing we're going to do is find the class boundaries. the class boundaries. To find the upper class boundaries, you're going to add 0.5 units to the upper class limit, and then to find the lower class boundary, you will subtract 0.5 from the lower class limit. The simplest explanation to understand why we add 0.5 units to create a class boundary is to ensure that the data will fall in just one class when we draw our histogram. Histogram bars must touch each other. Adding the 0.5 assures us that no data will fall on the boundary or bar lines of the histogram. Midpoint. For each class, you calculate the midpoints. Lower class limit plus the upper class limit divided by 2. And for our first one, 1 plus 12 divided by 2 equals 6.5. So we'll fill it in our table. Notice our class boundaries. We would subtract 0.5 to the lower limit, and we would add 0.5 to the upper limit. So it would become 0.5 to 12.5. All the data would fall within that range would fall right perfectly in between these two. Notice my midpoint is 6.5, and then you would just calculate the same for all of these. I just explained to you the first set. Frequency refers to the number of data that fall within the class limits, and that would be the number of data from our Excel spreadsheet that fall between 1 and 12, or 0.5 to 12.5. We can tally these values. If you go back to the Excel, you could tally these. In other words, between 1 through 12, we have 1, 2, 3, 4, 5, 6 data that fall between 0.5 and 12.5. And that's the frequency, the number of data that fall within that range. And you do the same thing for all of those. And so this is what we end up with. In other words, 6 data fell between 0.5 and 12.5. 10 data fell between 12.5 and 24.5. 5 numbers fell between 24.5 and 36.5, and so forth and so on. So there we go. Now we're going to talk about relative frequency and cumulative frequency together. But let's talk about the definition. Relative frequency is the class frequency, the number of data that fell between 0.5 and 12.5, divided by the total of all frequency. In this case, it's 6 divided by 42, because there are 42 values or data in this problem. When we divide this, it becomes 0.14285, etc., etc. We'll just round it and leave it at 0.14. And then you're going to do that for each of the different class limits. So there's our relative frequency for each of these limits. Okay, the cumulative frequency, as you can see, is just adding as you go along of the frequency. So we start out with 6 for the frequency and the relative frequency, and then 6 plus 10 is 16, so you're accumulating or cumulative, adding as you go along. And then 16 plus 5 is 21, then 21 plus 13 is 34, 34 plus 8 is 42. Notice if you add the relative frequencies, you will get 1. If you add the cumulative frequency, you will get 100, or 100% of all of the data values. Okay, let's talk about how to make a histogram. So you've got your frequency table, and then we have all of that. And then now you're going to place your boundaries on the horizontal axis and the frequencies or relative frequencies on the vertical axis. And then for each class of the frequency table, you're going to draw a bar whose width extends between the corresponding class boundaries. So the histogram, the height of each bar is the corresponding class frequency. The relative frequency histograms, the height of each bar is the corresponding class relative frequency. So let's look and see what it looks like. Okay, if you can tell what this looks like. All right, this is pretty much it. Notice that your frequencies are in the y-axis, and keep them uniform. In other words, if you're going 0 through 2, 0, if you're going to do it even, like 2, 4, 6, 8, 10, 12, 14, etc., that's how you keep it. If you do 1, then do 1, 3, 5, 7, you know, it's your preference, but Also, notice that the size should be relatively the same from here to here, keep it uniform, as well as from here to here. Okay, so this histogram has your first class 0.5 to 12.5, 12.5 to 24.5, and so forth. They must touch. The first class, which is 0.5 to 12.5 for the class boundaries, there are 6 data. 6 data, see the 6? 6 data in this class boundary. The second class boundary is from 12.5 to 24.5, and the number of data in that boundary or class is 10. And you do the same thing for each of these. And that's the histogram. Do you remember when we were doing the relative frequency and we came up with 0.4 and then 0.24 for the next class? Well, if you multiply that by 100, you'll get a whole number. So the first class from 0.5 to 12.5, if you remember, the relative frequency was 0.14. Multiply that by 100 and you get 14. So the next one was 0.24, and when you multiply that by 100, you get 24. So this is where this is, and so forth and so on. So when you do the relative frequency, if you remember up here in our values, let me go back up here. 0.4 times 100 is 14. 0.24 times 100 is 24. This would become 12. This one 31, and this one would be 19. And if you go back to the diagram here, the histogram, for the relative frequency, that's exactly what we did. The next thing we're going to talk about is basic distribution shapes. There are 4 main shapes. You have mound-shaped symmetrical, uniform or rectangular, skewed left or skewed right, and bimodal. So if you look at the mound-shaped symmetrical, this is the one that has that bell curve look. The next one is uniform or rectangular, and you see that it's quite obvious your data when it falls, it will look more or less very uniform, the same size, and usually is rectangular. The next one is skewed left. Skewed left, it starts down low, and the bump, if I trace this, would go to the right. So it's kind of the opposite. Skewed left means the highest peaks would be on the right, and the skewed right, the highest peaks begin and the lowest part is to the right. The bimodal histogram, you've got some peaks right here, the highest points, but they're separated by other classes. Notice we have 2 high frequencies right here up at the top, and then we have at least one class that separates the 2 of them. So our basic distribution shape for our graph histogram would be bimodal. And then OGIVE. OGIVE is taking the histogram and connecting the dots. Take the information from your frequency table for each class. You will make a dot on the histogram where the upper class boundary is located with respect to the cumulative class frequency. So in this case, you have 6 for the first class, then you have 10, and so forth and so on. You just put a dot in the center, like where the midpoint would be. But when you make an OGIVE, it always begins with the first class's lower class boundary, which is located on the x-axis or the horizontal axis, which would be 0.5. And then once you make your dots, then just connect them and make a line. And that's it for problem number 13. Now you should be able to do problem 11. Thank you.